Yes, good morning, everyone. What we have discussed in the last class? Okay, DHCP. So we discussed about DHCP. We use DHCP to assign IP addresses automatically to the host. Now, it is going to have port number as 67 and 68. And what it uses? UDP. Then it operates on a DORA process where we have discover, offer, request, acknowledgement. Correct? Now, in this discover message will be sent by whom? The client side to discover the server who can allocate the IP addresses. Now, in this case, it get IP address information, then it gets subnet mask information, default gateway information, and even the DNS server information. Now, it is going to have a lease time, means whatever the IP it is getting, it is not going to be permanent in nature. Then we discuss about DHCP relay agent. In this, what happens that we will be having one router and the server will be located in different network, whereas host will be located in the different network. For that, we require a one more router that will be acting as a DHCP relay agent. So this router is responsible for collecting the information from where? From the server or sending it to the host. Correct? And for that, we need to configure one IP, means one configuration, that is IP helper address. And here we will write the address of whom? Address of the server, or we can say that the router where we have created the pool. Right? Then we discuss about DHCP snooping and spoofing concept. So why do we need this DHCP snooping? So that if there is any rogue DHCP server, it cannot allocate the IP addresses to my host. That's why we need a DHCP snooping concept. Under that, what it does, it will make a particular interface as a trust interface. And if anything is coming from the trust interface that will be accepted, means that IP allocation will be coming from the trust interface. So it is going to be accepted that. If it is coming from any untrust interface, it will be denied. Correct? No? Then we discuss about what? DNS. Where we have discussed that DNS is going to use what? Port number is 53 and it uses TCP and UDP. Correct? And even it has certain zones. So today we will be starting with the Syslog and SNMP. I think already I have discussed regarding NTP, Network Time Protocol. So first we will discuss about the SNMP. See what happens that why do we need this SNMP and Syslog? We will be having multiple devices, right? Let's say we are going to have a router only. So we will be doing the configuration on the router. Now I want to have all the configuration that we are going to do on the routers. We want to have a central management system where I can get all the configuration information on the centralized device. For what? This can be used for management purpose. In this case, what happens that rather than going on the individual devices and collecting the information, what happens that we will be having one protocol based on that protocol running over the devices. It is going to collect the information from all these individual devices and put it on the centralized devices. Right? So these devices where it is going to have all these things, we can have this like a server. Right? Now what happens that in the SNMP, it is based on the current event. It means that whatever is happening now, everything will be stored. Whereas Syslog is also like a management protocol only, but in this what happens that it is going to have the information regarding the historical event. This is the major differences between SNMP and the Syslog. So this one, current event, and whereas Syslog will be doing the historical event that has occurred in the past. With the help of SNMP, what we can do? We can make the changes on the devices also. From where? From the centralized device. We can do the changes also. But in the case of Syslog, not possible. Just you can collect the log information. You cannot do any troubleshooting from that particular devices. You need to go to the individual devices for doing any changes, right? So what it says, SNMP is an application layer protocol that provides a message format for communication between what terms as a manager and what terms as a agents. In this SNMP, we have a concept called as a manager and agent. Who is the manager? The devices on which we will be having all the device information. That will be called as a manager. And who is the agent? The individual devices that is sending its log to the manager. These devices will be called as a agent, right? So that's why it's telling you that we will be having certain termed as a manager and agents. So an SNMP manager is a network management application running on a PC or running on a server. So where we can have this particular manager on a PC or on a server. Now, with that host typically being called as a network management station, many SNMP agents exist in the network. We can have multiple agents, right? Let's say I'm having 10 different switches. Now, whatever the changes, whatever the configuration we are going to do on this switches, we want it to have a log activities stored at a centralized device that can be a server. So here server will be called as what? Manager. And this all individual devices will be called as what? Agent. That's why it's telling you that we can have here multiple agent. So many SNMP agent exist in the network, one per device that is being managed, right? Now, the SNMP agent is a software running inside each devices. Like I told you that if I'm having individual switches, and here I am having a centralized device that is called as a server, where all my information regarding this agent will be stored. In that case, I need to have certain software running on the individual devices. Like for whatever the configuration I am doing, in background, there should be some software who is collecting all this information. Like for example, when you check in your own laptop task manager, it shows all the details about the running configuration on the laptop. How it shows? Like it will show you that this is the RAM utilization, CPU, everything. It means there is some software that is collecting that information and it is forecasting to you. But here what happens that everything I am doing on my laptop, it is available also, but I can check this all activities were on my laptop only. But in the case of SNMP, what happens that whatever it is happening, a software will collect that information, but rather than displaying it from that particular devices only, it will send that information to the other device. That could be like a server. So that whenever there is one individual, if he wants to see all the activities running on this particular device, no need to go to the individual device to check that. It can check it from where? Server. Manager, that we can say. Okay. That's why it says that the SNMP agent is a software running inside each devices. It can be a router, it can be a switches, right? And with knowledge of all the variables on that devices that describes the device configuration, device status, and counters, the SNMP manager uses SNMP protocols to communicate with each SNMP agents. What the point? Why do we have this SNMP? What is SNMP? Everything we discussed, but we have not told you that full form. It is Simple Network Management Protocol. Simple Network Management Protocol. It is an application layer protocol that is responsible for collecting the logged information or configuration information or device status from different individual devices that is called as the SNMP agent. And this information will be delivered to the SNMP manager. Is it clear till here? Now see what it says. That each agent keeps a database of variables. Like here I was telling you that we have a task manager where we can check all this information. Same as in the case of SNMP, what happens that when the agent software is collecting the information from the SNMP agent devices, it is going to maintain all that information in a database. And that database will be called as what? MIB. What is MIB? Management Information Base. So that makes up the parameter, status, and counters for the operations of the devices. And this database will be called as management information base. So it means that whenever the agent is sending information regarding the devices to the SNMP manager, it will send what? MIB files. Okay, so see, it is telling you that this is the Cisco router we have, and there is one agent, SNMP agent software. It is collecting the information in a MIB file, and it will send this MIB file to whom? To SNMP manager. Clear? So you need to clear with all these terms: managers, agents, network management system, MIB files. Now see what it says, that the NMS, that is network management system, typically pulls SNMP agents on each device. Now the NMS can notify the human user in front of the PC, or it can send the emails also. What it is telling you, that let's say, for example, there is a individual devices, 4 devices we have taken. Then we have a server. It collected the information. Now what it says, the NMS can notify the human user in front of the PC, or it can send the information, or it can deliver the information directly, or it can also send you via emails. This feature is not present in the case of Syslog. Okay. It means that, let's say, for example, you collected the information from an individual device. Now the status of that device was not proper. It was not working properly. So what will happen? One mail came that regarding that this device is not working properly. And where you will get this mail? On the email that you have provided. So device status I will be getting on my emails. And this case is there in the case of SNMP. This feature is not there in the Syslog. Okay. So, and see what it says, that so on to notify the network operation staff of an issue identified by the data found by polling the devices. And you can even reconfigure the devices through these SNMP variables in the MIB files. And this configuration was not allowed in the case of Syslog. Just you can see that things. You cannot do any changes over that. But in this case, we can do the changes also. So specifically, the NMS uses the SNMP get next, and SNMP get bulk messages together, reference as simply get messages. What is used? Why do we use get messages? Get messages is used to retrieve the information from SNMP agent. Whatever term I'm writing, you have to note it down. Get message is used to retrieve the information from SNMP agents. So to ask for information from where? From the agent. Once you get the messages from the SNMP agents, Let's say you want to do certain changes on the agent from the manager side, you will send a set messages. Set messages to write the variables on the SNMP agent as a means to change the configurations of the device. So what we can write? Get request, get message is from SNMP manager to agent to retrieve the information. Whereas set message is from manager to agent, but this time manager will send. In the previous one, it was sending, only manager was sending, but it was sending it to collect the information from the agent. But this time he's not sending to collect, but he's sending for modification or configuration. And once you are giving a get request, so in that case, what will happen? The agent will respond. So we will be having one SNMP get response as well. Right now. So let me compile all the information that we have discussed till now. Okay. So this is a device like PC or server where all the information regarding the agent will be located. Let's show this all the comes. So what is that SNMP? Simple Network Management Protocol. It is used to collect information regarding the device configuration and its status and send it to the SNMP manager. Then we have as a SNMP agent. So these are the devices like router or switch where the software will be running and it will be collecting the device configuration and the status of device performance and will keep the information in MIB, that is called as a management information base, and send it to the SNMP manager. Then what is that SNMP manager? This is a device like PC or server where the all information regarding the agent will be located. Get request. This is a request message from the SNMP manager to agent to collect the information from the SNMP agent. Get response. This is a response message from the agent to the manager in response to the manager request. And finally, we have set request. So this is a request message from the manager to the agents to change any configurations or modification on the agent devices. Clear it is? Now, there are certain messages in the case of SNMP. Here we have two types of messages. One is trap and one is inform message. So what is this trap message? See, SNMP trap. SNMP trap available since the first version of SNMP from the late 1980s. That was called as a SNMP version 1. Okay. So this is available since the first version was launched regarding the SNMP that was in the year 1980. Now what happens in the trap message? See, it uses a fire and forget process. It means here it will send and it will forget the things. Okay. So SNMP agents sends the trap to the IP addresses of the NMS with the UDP as a transport protocol with all its SNMP messages with no application layer error recovery. And if the trap message arrives, it's great. If it is lost in transits, then it is lost. It means in the case of trap message, we can say one more thing that no acknowledgement is required. What is not required in the case of trap message? Acknowledgement is not required, right? It means just fire and forget, just send. They're not worried whether it is reaching or not. That's all. Whereas we have one message called as an inform message. This is like a trap message only, but with little reliability that is being added. So this inform message was present from the SNMP version 2. It means till now you came to know that SNMP having two versions, 1 and 2, right? It is mentioned also, but it has three versions. We'll discuss that. Now what it says that the NMS must acknowledge the receipt of the inform with an SNMP response message or the SNMP agent will time out and resend the inform message. Right? If agent is sending something, it wants to get a confirmation, acknowledgement if it is sending in the form of inform message. So this information in this inform message was not present in the case of SNMP version 1. It was present from which version? Which version? Version 2. Now see, it says that note that trap and inform both have a useful role today, and traps are still frequently used, both in the NMS. Trap uses less overhead on the agent, while informs improve the reliability of the messages but require a little more overhead effort. As it requires a confirmation message, that's why it is telling you that it requires more overhead effort, and that's why it is a reliable also. Understood this part? So how many types of messages we have in the case of SNMP? One is trap message and one is inform message. So both these messages is from which direction? Agent to the manager. When the information is coming in the form of trap, in that case, SNMP agent does not require any acknowledgement or confirmation message from the manager. But when it is sending in the form of inform message, it requires the confirmation message from the manager. Trap message was present in the version 1, whereas in the version 2, we have both trap as well as inform message. Got, got the idea? Or is it confusing? Huh? Because you are for the first time you are listening all these things. That's why it is confusing for the first time. But once you will go through the PPTs, it will be clear for you. Okay, what we are discussing, all the processes that the SNMP will be using to send and receive the informations. Okay, for you, one task. Note down the task. You will let me know what type of message agent will send in trap and what type of message agent will send in inform. Got the question? What type of messages SNMP agent will be sending in the trap message and what type of information it will be containing in the informations. You have to search about this. Any questions? Any questions still here? Then we can make changes from managers to the agents. Yes, and that changes will be applicable to the, or we can have a control on the agent devices through managers. That's why I told you. Okay. Now, in the simple network management protocol, it has three different versions: SNMP version 1, SNMP version 2C, and SNMP version 3. Means you can say 1, 2, and 3 like that. So SNMP version 1 was released in the year 1988. It was the first version, and it provides a framework for monitoring and managing the devices across our network. Now, why do we use this all protocols? For monitoring and management of the devices, right? Now, SNMP version 2 came in the year 1993. Now, what is the improvement compared to what we had in the SNMP version 1? See, in this, we were getting just GET request. First thing. Then, in this, trap message was present. But in the case of version 2, here it facilitates efficient retrieval of the large amount of data in the fewer seconds. It means in the SNMP version 2, we get the get bulk messages. This bulk messages information was not present in the case of SNMP version 1. So here what we can do, we can retrieve large amount of data compared to what we had in the case of version 1. Okay. And they both uses one concept like a password concept. Means security was there between them, but the problem was just it used to give the password. But in the case of SNMP version 3, it provides you more security. So whatever the retrieval of the data will take place, it is going to be secure. Fine. No? Like how we had Telnet and SSH as we discussed. So it is going to provide you more advanced security. Which one? Version 3. And in the version 2, we were having one option to get bulk messages. And also we had one information here. Okay. Then we had the latest one is SNMP version 3. It was introduced around in the year 2002. So SNMP version 3 addresses the critical security gaps that were found in the earlier versions. So it ensures data has not been tampered during the transmissions. How? Because it provides you encryption of the messages. Encrypt the message to prevent unauthorized viewing or unauthorized access of that particular messages. Right? Even it is going to provide you what? Authentication, like validates the identity of the users and devices. If you remember when we were starting the IPv6, that I explained you one concept that is called as a AAA. Authentication, authorization, accounting. So here it is going to check authentication. What is the user's identity? Who is going to collect the logged information? Who want to see the logged information about the individual devices on a central manager? Right? No? So this all advanced features was present from the SNMP version 3. Now, as I told you that version 1 and 2 were using a common password feature. So that was called as a community string. So community string is essentially a password or access control mechanism that allows the SNMP managers, that is a monitoring tool, to communicate with the SNMP agents, that is the networking device that is being managed. So in the case of version 1 and version 2, we were having a password, and this password is called as what? Community string. Whereas this community string has been replaced. SNMP version 3 replaces this community string and with the user-based authentication and encryption. Version 3 has replaced what? Community string, no, the normal passwords, and it has replaced it with what? user-based authentication and also with the encryption. Okay. Now here it is explaining you the types of community string. It says one is RO and one is read write. Now, whenever you set the community string, you set one criteria that I am setting it for read only. It means what will happen? This allows the SNMP managers to retrieve the information from the device but could not make any changes. When you write, it is for read only. In that case, manager will collect the information from the agent, but it cannot do any changes on the devices. And then we have is a read write. So it allows both retrieval and modification of setting or the configuration on the devices. In the case of read write, it is going to give you the options to retrieve also and to do the modification settings on the SNMP agents. Okay, that's why it is telling you that common default community strings are read only and read write, which should always be changed for the security regions. So these all things will be written when you are setting the commands. So you will write that all these features will be allowed, whether it is RO or RW. Got the point? So when a device like a router or a switch boots up, then SNMP agents initializes that. This agent is a software component that collects and sends the information about the devices to the network management system called as NMS. The SNMP agent uses the MIB, which is a structured database of information about the managed device. And the MIB contains the objects and can be managed, such as device status, performance metrics, and configuration parameters. So SNMP uses a request response model for communication between the NMS and SNMP agents. And these are the main types of messages. Get. So NMS sends a get request to retrieve the specific information from the managed device. Set. The NMS sends the set request to modify the configuration of the managed device. Get next, like when you have get, further you want to get the next, then you will write here what? Get next, the NMS retrieve the next object in the MIB hierarchy and the trap and inform that we have discussed. So trap sends a trap message to the NMS to report significant events or alerts, whereas information similar to the trap, but it requires acknowledgement from the NMS ensuring the message was received. Is it clear? So what it uses? SNMP uses UDP port number 161. What it uses? SNMP uses UDP port number 161. 161 also and 162 also. Because we have two-way communication, like how we had in the case of DHCP, client and server model, 67 and 68, like that only. Correct now? So we can write here. SNMP uses UDP port number 161 and 162. Cisco Packet Tracer does not support SNMP. Okay, if you know all this information regarding SNMP, it's fine. Okay, and one task I have given you to search what type of information you will get in the trap and what type of information you will get in the informaces. Got? Then we'll understand what is the differences and why do we have then syslog. See what it says here. That syslog is a standardized protocol that used for forwarding the log messages and events notifications generated by the networking devices to a centralized syslog server or a collector. Same function, but here also we'll be having the devices, individual devices, that is going to send it information to the home, to the syslog server. So syslog is what? System logging protocol is a standard way to collect and store the log messages from a different services like routers, switches, firewalls, servers into a center service. This helps in monitoring and troubleshooting and security auditing of the devices. So what it logs, what are the information it is going to collect? Example, like interface status, whether the interface is up or whether the interface is down. That information you'll be getting in the case of syslog. Then login attempts. If any other user is trying to log into your devices, how many attempts he has done. Then if there is any configuration changes, if there is any configuration changes on the devices, that changes also will be delivered to whom? To the server, central servers. So all this information you'll be getting from where? From the individual devices that is being managed. And one more at last we have, that is security warning and errors. If there is any error in the devices, okay, let's say your device is not working. So different criteria is there. Different security warnings is there. So based on that number, you will be identifying what is the status of my device. And in that case, it will send you what? A warning messages. Okay. So what are those warning messages that we have to see here? Okay, first see what is this log generation. It says that devices and applications generates the log messages containing the information about events, errors, status change. These logs includes a variety of details such as timestamps, time, severity labels, and descriptive messages. So here we will be understanding what is the severity labels. Based on the different severity labels, it is going to identify the status of the devices. For example, if I am getting, let's say 0, my severity level is 0, it means it says that your device is working. Example I'm giving. It can change. See what will happen. In this you see what it says. Number is there? No. 0. What is the number? 0. What is the keyword for this? Emergency. It means if anytime you are getting as a 0, it means you will come to know that this is an emergency message. And what it says, the system is unusable now. This is a very severe message, right? So in this type, in the syslog, what we have? A originator. Like how we had agent and manager, here is called as an originator that is going to generate the syslog content and that to be carried in a messages. And here it is a collector that gathers the syslog content for further analysis. Now, when you have a originator and collector directly connected, then this is a normal scenario. We may also have a relay device. Means there could be any mediator, intermediate devices who is collecting, then forwarding it to the this one collector. Like how we had the DHCP relay agent concept, like that. So a relay is what? That is going to forward the messages, accepting the messages from the originator or other relays and sending it to the collector. Right? You have to remember about this, about messages. If you are getting one, it means this is alert. In this, it is immediate action is required. Then we have critical, two, critical event, error, error event, warning, warning event. These are the impactful. This is the severe. Compared to this is not like very much dangerous, we can say. Originator, originator will send to the collector. Okay. Now, if everything is normally working, then notification, normal. Informational, 6. And last one is for debug, requested by the users to debug any particular information. Okay, how will you remember this? Okay, with this you can remember. Like here we have written emergency as a every, alert as a awesome, critical as a Cisco, error as a engineer, warning as a will, notification as a need, information as ice cream, and D as a deal. So like every awesome Cisco engineer will need ice cream daily. So we'll start from number 0, you will end at 7. This is a sequence. Is it clear? Can you see the bit? Yes, we'll see. Until here. Let's take a router. And switch. And we'll take one server. IP address will be here. 192.168. 1.1/24, and this side is 192.168.2.1/24, and for the server 192.168.2.2/24. Come to this router, give no, enable config space t, host name as router r1, interface is G0/0, IP address is 192.168.1.1.255.255.255.0. Give here no shut, give here exit. Interface G0/1, IP address is 192.168.2.1, 255.255.255.0, and give here no shut and give exit. Then come to the server, desktop IP configuration. IP is 192.168.2.2. And here we need to write our default gateway also. So 192.168.2.1. Done. Come to services. See here syslog we have. Logging. Give a question mark. First we will write here logging as on. Okay, logging on. Then logging host. Give a question mark. What it is telling you to write. If I'm writing here logging host, it means it is asking me to write the syslog server IP address. What is that? 192.168.2.2. Logging host we have given. Then if I'm giving you here logging trap message, see that we don't have to specify trap message, no? It will send according to the device status. Now, if I will send here a trap message, let's say, for example, I'm writing a debug. So it means that I am setting that if anything is happening, then I should get the information from 0 to 7 all. If here, instead of writing here debug, if let's say, for example, I am writing here as warning. So I will get the message warning, error, critical, alert, emergency. I will not get notification, informational, and debug. Getting the point? If I will write that I want the message as a from informational, then I will get informational, notification, warning, error, critical, alert, and emergency, not debug. Okay, so it means we are referring here that what type of information I want. So I am writing here till debug. It means all the information. If anything is happening, just send it to me. Logging, trap debugging, line console 0. See, why do we give this line console 0? To show that this is not, we are collecting it from virtually, but we have a connectivity. And at last, we need to give here logging synchronous. Okay. Do we have any other things? Logging, host. Now, if I will write here ABCD, means if I will write logging an IP address, it means this is going to be the IP address of whom? The router. Okay. So what is that? 192.168.1.1. Okay. Given all this point, if I will do certain changes on interface G0/0 only, make it shut. If exit, make it no shut. Okay. Interface G0/0, make it no shut. Give exit. See the message. Getting the messages? What is the message you have got? Interface up, interface down. Getting? I am changing the status of the router. I am getting that. Right now, how I'm getting? Because I have configured here that whatever the changes I'm going to do on this router, you have to send these changes over the server. So I have all of the commands I have given. First is logging is on. Second is you have to write here. Let me write the commands first. Syslog command. What we write? Logging is on. Then what we have written here? Once logging is on, then logging host, logging host. And here we will write the IP address of the server. Next, logging trap message, right? So logging trap, and that here trap message from where you want to have a logging for that. Then what we write? Line console 0 and logging synchronous. And at last we write here logging and the IP address of the originator device. Right now, who is going to have all this logged activities on a server. This is all the commands that we will be giving. Why not? We should have a centralized device, no, where you will be collecting all the information. Understood this?
Can you explain the login trap messages?
Trap messages. So,
it's working?
Huh?
How it is working on the
Let's say, for example, that here I have delivered in the command that I want the trap message from the debug till debug. Means if anything is not working, there is certain problem with the devices. Okay. So in that case, if devices is highly unusable, like it is unusable, then you will get the message as a numerical value 0. In that case, you will come to know that if I'm getting numerical value as 0, then this is what type of message, emergency message. It means my system is unusable. I need to go and I need to troubleshoot that. It is, you can say, it is like a categorization of the messages in the case of Syslog. And what type of categorization? The behavior or the functioning of the devices. What it gives you the information, functioning of the devices, how your device is functioning, normal or not normal. And when we write the command, that trap message, so you specify that I want the information till this trap message.
Like if I have to see all the message, I have to write debug.
Yes. So that you have to see if anything emergency, I should get alert, I should get critical, I should get same as error, warning, information, notification, and debug. What if I'm writing logging trap message is warning? I will get when anything is not working, emergency I will get, alert I will get, critical I will get, error I will get, warning I will get, but notification, information, and debug I will not get. Because only I have said that.
What about the line console 0?
Line console 0, it means that it is going to give you the information regarding, see, console means what? Console means we are not actually taking it virtually, remotely. Right? I want to access it through a console cable. And how many person will be allowed to access it? Only one person. That's why it is 0. Remember, when we were configuring that particular telnet, what we write? Line VTY. Why VTY? This is for virtual terminal. It means if anyone is accessing it remotely, then how many users you are going to allow there?
0, 1, 0,
2. Like 0, 1, 0, 2, like that we specify, right? But here I am specifying it console. It means I'm not allowing any remote access. Getting? I'm allowing what? Console access.
like we have to connect the server only through the cables.
Right. That's why I'm allowing it console. Right? No?
Logging synchronizing.
So that whatever is happening here, it should be synchronized one by one. It means that if I have, let's say, changed this one and this is coming at last, if I have done anything changes now, it should be present now only, no, at same time, no, so that we can troubleshoot it at what time that changes has occur. That means synchronization should be there. Got the point? Understood this?
We want to syslog messages from.
Hmm?
We want to like syslog log messages from PC.
Huh.
How?
Same thing, you can configure there. No? But generally what happens that we will be using this for the devices. Like we have firewalls, routers, and switches like that. Correct? Because in general, why what is required to have that devices? Because if you will be having all these end devices, you can see there and there only. Huh. Switch also, huh? Same commands. Correct? So what again switch this syslog is using? Same UDP and port number is what? 514. It means both SNMP and syslog uses what? UDP only.
The numerical value servers. This type of which type of this
Mm-hmm.
how to identify the using numerical values in this chart.
You will get the message, no? When you will get the message, you will come to know about that. Here it is not showing you, but you may get that. Okay, search on the Google about show me the chart of actual messages that we can receive on a syslog server. You will get that.
This is not the actual.
This is not like actual what we should get. And we can do it, but you can search about that. It will be fine. It will show exact images. Okay, so like this, we can clear the log as well, so that everything will be deleted. So this is regarding syslog and SNMP. Next we have is a FTP and TFTP. Okay, see here only. So what is TFTP? It is trivial file transfer protocol. See, why do we use this FTP and TFTP? In general, to copy running configuration and to copy startup configurations. Now, what happens that, let's say, for example, we have one device, a router, and we have a server. Now, whatever the running configuration I'm going to have, in this case, I will give a command copy running configuration using the protocol TFTP. And for that, you will mention the IP address of the server, IP of server, where you want to have this particular copy. The reason, because let's say we are going to have so many commands running on the router. If at any point, if my router stops working, or if all the commands are deleted, I should have the copy of that. So backup, we can say. So if at any point this device is not working, then if all the thing has been erased, so that we can have a backup and we will copy it from the server back to the router. This is a use case of trivial file transfer protocol. Now, difference is that, see, this is a very simple transfer protocol. It is not used to transfer the files over the internet. It means in this, TFTP will be used only when your routers, switches, or your servers will be located in the same LAN. Means the server should be in the same local area network. It should not be in a different network, right? Now, it is generally used to transfer the files in local area network. Where do we use this point? In a transfer to file in the local area network. It uses port number 69 to send to have the traffic communications. And it is primarily used where in the LAN environment. So it is commonly used within the local area network. Now, due to its simplicity, it lacks any encryption or authentication. We don't have any encryption in the case of TFTP, right? Whereas in the case of FTP, this is called as a file transfer protocol, and it is used to transfer the files over the networks. This will be helpful for the web hosting, and it is going to operate over the TCP, and it is having the port number is 21. So it supports what? Authentication. It provides you a user needs to log in with their username and password for having the FTP, file transfer protocol. So in this case, in our FTP, we can have our devices and the server devices located in different network. That's fine. Because here we can transfer the file outside our own network. And for that, we may require what? Internet. Correct, no? So we'll see the TFTP configuration. And where is TFTP? Yes, see. If in the FTP, you can transfer data also, files also, configuration files. So if you're sending FTP data, then it is going to use port numbers 20 TCP. And if you're transferring any FTP control like files, configuration files, then it is going to use a port number 21 and it uses TCP. Huh? Controller that through which you can control the devices. This is a different file. This is a different file. This is a file where your normal data will be present. Other than this, here we will be having all the list of different files where we can control the devices like configuration files. Okay. TFTP uses what? Port number 69 and it uses UDP. So TCP, so FTP is reliable but slow. TFTP is fast but unreliable. We'll take a router. We'll take a server. IP will be 10.1.1.1. and this one is going to be 10.1.2. Configure the IP. Now, if I will give here WR, it means what? Write up command. So what will happen? All the commands will be saved here with the help of write up command. Then what you are going to do here, you want to copy. So first that, before that you write the assigned IP to the server. What is IP? 10.1.1.2. Come to router and give a command, copy running config tftp what we have given, copy running configurations where tftp, it is asking you to write the address or name of the remote host. What is that? 10.1.1.2, where I want to copy that. Now, you can also give a name to that, or otherwise it will take automatically. We have to use in the privilege mode only, yes. Like I'm writing con. This is my configuration file. Done. It has been copied. Now I want to copy one more startup. Copy startup configuration. Where you want to copy? TFTP. What is the host address? 10.1.1. File name, let's say start. My file name. Copied. Come to server. Services. TFTP. Okay. See, it is registered. No. See, start. And event con. It's present. Let me remove other. Both are present. Con and start. Both the files. If any of the file is not present in the case of routers, then what will happen? You can copy it from the server to the router. Fine. So for that, let's say we will be erasing that. In real scenario, don't prefer this. Yes, erase startup configuration. Erasing the environment, confirm, yes. So if I have erased the startup configuration, what will happen? Everything will be deleted now, right? So if everything is deleted, it means if you will check show IP interface brief, okay, it is present, but the startup configuration has been deleted, right? Now for that, I need to have a copy for that. How will you get it back? For that, you need to give command copy. This time, first we used to give the command when you want to copy from the device to the server, you write here run copy running configuration startup configuration to the TFTP. This time I will write copy from where you want to copy. I want to copy it from the TFTP. Now what you want to copy? The startup configuration. Then it will tell you, give me the name of from where you want to copy. 10.1.1.2. What is the file name you have given? Start. 69 bytes of information has been copied. Okay, this is how we can copy from the device to the server. And if the information is deleted, then you can copy from the server to the devices also. Note down this command. to copy files from device to the server using TFTP. For that, we used to write here copy in the enable mode only, running configuration. Then we used to write here TFTP. Then it will ask you to write what? The address of the server. So you will write here address of server. It means in this case, you will write here IP address of the server where it has been located. Then what you write? File name. If you want, you can give, otherwise it will take it automatically any other name. Same as you can do it for the startup configuration as well. Clear? No? Understood this? No. Which one? This one or that I have written in the pen? Huh?
We'll copy from server to devices. They will address we need.
Server IP only.
Done.
For FTP, you can write the command. But local file name this is going to be used to upload. Just wait, I'm getting up. 1 minute. Okay. So this is we are going to use when we need to upload from local to the server. From local device to server. Put local file and its name. And to get it from the server, to get from server to the local device, they will be using here get remove file and the file name. Okay, understood?
Yes. When we upload any file or Gmail drive or download any file from that drive, then FTP to
No, there is different protocol.
for like uploading and downloading.
For emails, we have different. We'll discuss that. So one is the IMAP, one is the POP3. Okay. So email exchange document is there. So we'll discuss that. So we have to discuss about this email exchange. We have three protocols like SMTP, POP3, and IMAP. So we have to discuss differences between POP3 and IMAP. Then what is SMTP and what is POP3? Okay. We'll discuss in the next class. No problem. So in the next class, we'll start with this only email exchange. And further, then we'll start with the wireless. Fine. We'll stop the recording.